Hi there. Thank you for clicking on this video. This lesson is going to cover operations on square roots specifically, but we are going to delve into some other kinds of roots, like higher order roots, just a little bit because the principles are the same. So we're going to focus on square roots, and we're going to narrow this down to adding and subtracting. So a little bit kind of behind that in case you clicked on this video and you're looking for something broader than adding or subtracting. We've got adding, subtracting, multiplying, and dividing that we can do with square roots and radicals in general. Adding and subtracting work the same way, and to some extent multiplying and dividing work the same way, but division can get a little bit messy because we have a couple of math rules. So what I decided to do in planning out these videos is to do adding and subtracting together, multiplying in its own video, and dividing in its own video. So the videos will probably be a little bit shorter, which I don't think anybody would complain about. But also, if you're looking for like an overview on all of the operations, it means that you're probably going to need to click on more than one video, but the explanations for each should be pretty thorough. Please like and subscribe if you find this video helpful. Drop a comment to engage, and then check out the practice set for this lesson, especially if this is the first time you're going through it. You want to definitely test to see like, okay, did I understand what was covered in this lesson? So we're going to, as I always try to do, establish the concept. It's not just about can I get the problem right, it's do I understand the concept underlying it, because you can get problems right without really understanding why they work. And then when we kind of push into something a little bit different, then like it doesn't work anymore because we're not getting the concept. So I want to start with this idea. What is 2x plus 5x? Got to think about it for a moment. And hopefully you said that was 7x. Now that goes back to pretty early in algebra. We established the idea of like terms and what it is to combine them, and the variables have to match, okay? So you have 2x's and 5x's, so what do you have? You have 7x's, and of course that is 7 times x. Now, building on that, reflecting on what is a variable. So I have this variable there, the variable is x, but what is it? Well, a variable is a letter that represents an unknown number. Okay, so maybe it represents time, and time could be changing, and we don't necessarily know what time is. So maybe time is 5 seconds or 10 seconds. When you're graphing, when you have a variable, you can pick values for your input or your x, and then you find the y that it maps to. So it's a stand-in for a number that either we don't know or a number that could be changing. So again, like over time, something is changing. So, but the key there is that it represents a number. So here's the principle. If this principle works for unknown numbers, then it works for known numbers also. Okay, I'll repeat that so you can kind of let it sink in. If this principle works for unknown numbers, then it would work for known numbers. So, okay, so let's see what on earth is she talking about. So an example is always a good place to go. So here we go. We have 2 times 8 plus 5 times 8. Now, what I did there was instead of, it would be awesome is if I wrote the right number down. So I'm in the upper right-hand side of your screen. So I took the 2x plus 5x, and instead of the x, I'm putting in an 8. So we have 2 times 8 plus 5 times 8. Well, if 2x plus 5x is 7x, then 2 times 8 plus 5 times 8 would be 7 times 8. In other words, you can add the 2 and the 5. Okay, and the 8 would be along for the right. Now, I have written over there on the right, we can see this more than one way. So if I kind of lost you there and you're like, ooh, wait a minute, like what just happened there? Like we had 2 8s and now we only have 1 8. Like what was that about? Okay, I want you to think of it this way. And again, this is drawing on some of your other algebra knowledge, all right? So I'm assuming at this point that you know what it is to factor out a GCF. So looking at the 2x plus 5x, I see I have a common factor of x. So I'm going to go ahead and factor that out. And if I have 2x and I factor out the x, I'm left with a 2. If I have a 5x, I factor out the x, I'm left with a 5. And then, of course, 2 plus 5 is 7, and that gets me to the 7x. All right, so that's how you can picture that combining like terms. Now, it might be a little bit easier to look at this with the 8. I have 2 times 8 and then 5 times 8, so I could factor out the common factor of 8, and I would be left with 2 plus 5, and of course 2 plus 5 is 7. Now I've got that written as 8 times 7. Over here I said 7 times 8. We do know that those are the same thing, so I could just switch the order there around and you could say 8 times 7 is 56, so is 7 times 8. So you can actually look at that more than one way. The idea here is that I can do this with numbers. So, of course, the title of this lesson was adding and subtracting radicals. So let's see what it looks like with the radicals. So again, I'm keeping that 2 and that 5. All right, 2 and the 5. So before I had an x, 2x plus 5x. Then we looked at it with like, okay, 2 times 8 plus 5 times 8. Well, now we have a square root of 3, which is just a number. So 2 root 3 plus 5 root 3 must be 7 root 3. Okay, and yeah, and there you go. Now, if you wanted to, you could kind of look at it this way, where we see a common factor of root 3. We take it out as before. We've got that 2 plus 5 there. 2 plus 5 is 7, and there's your 7 root 3. Okay, so you could think of it that way. Now, we obviously do not want to keep going through that, but we could. Now, that is the underlying concept. Now let's summarize what we've just looked at. So key takeaways, okay? Key takeaways that we want to take away from this presentation. We treat the radical like we would a variable. If you can do, okay, I'm going to be up in the upper right-hand side of your screen again. If you can do 2x plus 5x and get 7x, then you can do 2 root 3 plus 5 root 3 and get 7 root 3. So that's a major takeaway that we want to get from this. And we do not operate on the radicands. So we're like, wait a minute, radicands, like what is that? That is the number or expression, if you've got variables under there, that's under the radical. Okay, it's the thing that's like right there under the radical. So we don't operate on them. So a common mistake students will make is they'll say, oh, well, root 3 plus root 3 is root 6. No, it is not. It is not root 6 for the same reason that like you don't say 2x plus 5x is 2 times 2x plus 5, 2x. Like you're not adding the x's together, okay? You're adding 2x plus 5x and you're not operating on the x at all. But somehow, when we get to the radicals, there's this tendency to want to operate on them. Now, again, that is the key concept, okay? So we can treat the radical like we would a variable. We do not operate on the radicands. So here are our key ideas. So if you've been listening to this for 8.5 minutes, haven't written anything down, okay, just kind of following along, here's where you want to start to write stuff down. Okay, the radicals must be like in order to add or subtract them. So just like you can do like 5x plus 7x, but you can't do 5x. I don't know why I changed the 2 there to a 7, but you can't do 5x plus 7y. All right, so you can add them in order to you can add them if the radicals match, okay? So if they are like radicals, same as with variables, okay? They have to match. And we treat the radical as we would a variable. So whatever you would do if you had an x in there, that's what you're going to do with the radicals, okay? So these are the key ideas. If I were going to be lazy and say, I want to record the shortest video possible to get more people to watch it because it'll be short, I would just jump to this. But you will forget this if it doesn't make any sense. We've got to go back and lay that foundation so that 2 weeks from now, you do not forget the concept in the lesson. So here are a few more examples to look at. I have 2 root 2 minus 3 root 2. And in this case, we can do the 2 minus 3 and the root 2 comes along for the ride. Well, 2 minus 3 is -1. And that's the root 2. And I hope I just said root 2 for some reason in my head. I'm thinking I said a 5, which there's like no 5 there. So the root 2 is along for the ride. And so we have -1 root 2. You could also simply say negative root 2 because multiplying by a 1 is, 1 root 2 is just root 2. So you could just say negative root 2 on that. For the same reason, if you had 2x minus 3x, you could say -1x or simply -x, okay? Both of those would be okay. Now, here I mentioned at the outset, we would take a look at some higher order roots, all right, because the same principles hold. So we have the cube root of 2x plus 4 cube root of 2x. And so in this case, this is the thing that we're treating like a variable, okay, cube root of 2x. So if I have 1 cube root of 2x plus 4 cube root of 2x, that is 5 cube root of 2x. So if you were tempted to try to do something with the 3's, like, nope, do not have to do that. And if you're like thinking, but why? Remember that these are square roots. Like up there's an index of 2 that we assume is there when we don't see one. And we didn't do anything with those 2's, okay? So we just had a square root when we were done. So you don't want to change the kind of radical or root that you have there. So those are just a couple of other examples. And remember, if you don't see a coefficient, the coefficient would be 1. Just like if you had x plus 4x, you would say that was 5x, okay? Because we would understand that that was 1x. All right, now watch out. We must simplify the radicals before we can conclude that they cannot be added or subtracted. So here we have 5 root 27 minus 4 root 48. And those radicals do not appear to match, but we do have to simplify them and see, like, well, can we get them to match? And so for this, I'm going to go ahead and simplify this out. We covered that in a previous lesson. I'm going to go ahead and link that. Radicals simplifying up here. All right. I don't know why I wrote the radical simplify instead of simplify radicals, but you get the idea. So if you need to look at that, like, how did you do that? What is the reasoning? Go check out that lesson. All right. So right here, we can do the prime factorization, and I'll just review this strategy. So 27 factors into 9 times 3, and then 9 factors into 3 times 3. And so that's 3 times 3 times 3. Now, over here, okay, I'm going to do this a little bit differently. I am not going to get it all the way to the prime factorization. I'm going to say that 48 is 3 times 16. And then I'm going to go ahead and factor the 16 into 4 times 4. Now, it is true that I could take each of those 4s and break it into 2 times 2 and 2 times 2, all right? But I know this is a square root, and I know I'm going to be looking for pairs of numbers, and so I have the pair of 4s, and I'm not going to break that down anymore. All right, now this is a square root. So we are looking for pairs. So there's a 3 squared and here is a 4 squared. And what that means is that the square root of 3 squared is 3. And so I end up with a 3 outside here and a 3 still left on the inside. And we have a 4 here. And the square root of 4 squared is 4. And I am left with the 3. And what we want to notice is that now my radicals match. So before they did not match, but now they do. And 5 times 3 is 15. And 4 times 4 is 16. So I have 15 root 3 minus 16 root 3, which is -1 root 3. Or simply negative root 3. So you do have to simplify them before you can just write it off and say, nope, cannot be simplified. All right. One last little detail. So what if we can't make them match? Okay. So we've got matching radicals, or we have things that aren't matching, but we simplify them, then they match. What if we can't make them match? What if we go through the simplification process and we still have unlike radicals? If the radicals don't match and we cannot make them match, then we cannot combine them. So simply like looking at that, we have the root 2 plus root 7. Okay, you can play around that for as long as you want, but they don't match. That's it. It's simplified already. So root 2 plus root 7. Do not say it is root 9 and then take the square root of that and get 3. Nope, nope, nope. Okay, it does not work. You could put it into your calculator and see that you have totally different numbers. That is simplified already. That is as far as you can go. So this is similar to if you saw 2x plus 3y. If they are not like, then we cannot combine them. 2x plus 3y is simply 2x plus 3y. That's it. Okay, so you can combine stuff that's the same, but not if it's not the same, and the same thing holds true for radicals. So please don't forget to give this video a like if you found it helpful. Subscribe to the channel for more math help. Drop a comment or question below, and check out the practice set for this lesson. I do up the difficulty level, so especially if you are an Algebra 2 student, if you're in an honors level class where you're really going to dive deep into this and you're going to be expected to move beyond like the easier problems and get into the harder ones, check out the practice set. I do have a variety of problems in that, and I hope to see you in a future video.